Hey, Math Ninjas. We're moving on with scientific notation, which is good stuff. It's needed. My definition of it is like it's a way to write really big and really small numbers in a clear, concise way. All right. And this is important mathematics. You can imagine if you're doing like astrophysics or molecular biology, then you're dealing with like huge values, right? If you're talking about galaxies all the way over there, or tiny, like cells, microbiology type stuff. Okay. So that's my definition. If you look it up in the book, it's going to say it's a number written in scientific notation, is when it's written as the product, multiplication, of a factor, a number, and a power, an exponent of 10, an exponent of 10. The factor, that number, must be greater than 1 and less than 10 to be considered written in scientific notation, for it to be in scientific notation. So, for example here, this is scientific notation. You've got a number, a factor between the value of 1 and 10, 4 and 7/10, times a power of 10. Here it is 10 to the power of 8. And so this is a clean way that you would see if you were working in molecular biology and astrophysics of working with a really large number. In this case, 4,790,000,000. Okay. That's how we want to do it. It's cleaner. It's more concise. All right. And then here in the other example, a number that's really small is working with a negative exponent. So here you got 1 3/10 to the power of 10 to the negative 6. Okay. And then if we expanded that in what we call standard form, then it's like this. It's that, which is what? Tens, hundreds, thousands, 10,000s, millions, 10 millions, 100 millions, 1,300 millionths. Okay. And you'll also see that the number of the exponent with a base of 10 tells you where to move the decimal point. So if we started here, right, you can imagine it's 4.7. I'm going to make that a decimal point for just a moment. Then I'm going to move the decimal point 8 places to the right if it's positive. So 1, 2, 3, 4, 5, 6, 7, 8. So I might even added in too many zeros there, right? I think that I did. So I'm glad that I checked that. So the decimal point to a power of 8 moves over 8 times. I'm going to check it. 1, 2, 3, 4, 5, 6, 7, 8. So yeah, that's it. So it's actually, let me take out my commas and put them in the correct place. So it's actually 479 million. Okay. One other reason why scientific notation is helpful, if you're writing a string of that many zeros, it could be less clear. Okay, good. So, and then here we can say, okay, let me try this. The decimal point was here. It's to the power of negative 6. So I move to the left now, making the value smaller 6 times. So 1, 2, 3, 4, 5, 6. So there, cool. I did that correctly. So those are some examples of scientific notation. Let's look at some more. All right. So here we're just, we're doing it. We're going to practice a couple. So that's a really big number, right? Like, what is this? Hundreds, thousands, millions, billions, right? So 970 billion. So we know we can look at this, and the first part of scientific notation is a factor between 1 and 10. So we know we're going to have this be equal to 9.7, right? That's between 1 and 10. Okay, good. And then it's going to be times a power of 10. Cool? And now I need to figure out how to what power of 10. So I'm going to imagine my decimal point here. And how many place values is it going to go? It's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these things are equivalent. 970 billion is equivalent to 9.7, 9 and 7 tenths to the power of 10 to the 11th. Okay, here I added commas. I actually don't think you use commas with decimal place numbers. Okay, so here we've got, we need, for scientific notation, it needs to be a factor between 1 and 10. So what we would say is we've got 2.4. That is between 1 and 10 times a power of 10 to what place value? So now we need to move the decimal to the right, and this is going to represent a negative exponent because it's a very small number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to the power 10 to the power of negative 10, right? Okay, so that's an example of how we're working with scientific notation, how you would work with these problems, and you're going to have some practice problems. So here are some practice problems. The first ones are to take large numbers or small numbers and change them into scientific notation like we were just looking at, okay? And then also want to practice putting them back into standard form, like expanding them back out, right? So here you have 7, right? And then you're going to imagine from like a decimal point moving over 7 times, okay? So just reversing the process that we had, you're adding 7 zeros to this. Here, you've got 8 to the power of negative 5. That's going to be a small number. And here you got to remember your decimal point is to the right of the 8. So you're moving over 5 spots, 1, 2, 3, 4, 5. But it's going to look like 4 zeros in front of the 8, right? I think you're going to check it. And here you've got 1 and 66 hundredths, right? It doesn't need to just be 2. That's the first time we've seen it with 3 like number values. So you're going to start at the decimal point. It's to the power of 9, 10 to the power of 9, and move your decimal point over that many times. So powers of 10 are clean and convenient to work with. This is scientific notation. Go do it.